Hello, so this is the video for discussion week 4 for PA4. So PA4 covers sets, multi-way, tries, and ternary search trees. I'm also going to give you a little bit of information regarding the midterm. So first, some reminders. PA4 is due Tuesday, April 28th at 11:59 p.m. The midterm is the following day, April 29th, Wednesday. And you have to complete the midterm sometime that day in one sitting. And you're allowed to use your notes, readings, and other resources, basically any resource, but no collaboration is allowed. So we are giving you a lot of information that you can use, so please don't collaborate, as that is an academic integrity violation. So how do you study for the midterm? Please study the reading quizzes, videos, STEPIC chapters, PAs, and then in the STEPIC chapters, and some of them, this is linked, but David Gaia has created these amazing visualizations which allow you to easily practice using these different data structures. And this includes all the material that was due before the exam. So please use these resources. Now, it's important to remember that practicing these concepts is the best way of studying rather than trying to memorize them or just watching the videos and assuming you understand the concepts. So it's very easy to watch a video and go through it and understand what's happening and therefore have this sense of understanding all of the material, which may or may not in fact be true. So it's very important to practice these concepts, and you can create your own examples, use STEPIC. If you create your own examples and then you use the visualizations I mentioned before, you'll be able to step through them and test that you implemented them and did them properly. So there are a lot of resources available. Also, if you have any questions, please attend office hours or discussion section or the problem sessions or anything. There are a lot of opportunities to ask questions, and some of the areas are underutilized, like office hours, so it should be pretty easy to get help from instructors. So now PA4, this consists of sets, multi-way tries, and ternary search trees. There are 4 parts to this assignment. Part 0 is the weekly reflection survey, and we really hope that you complete this, as it gives us information on how the course is progressing for you and how you think it's going. Then the second part is implementing the set ADT. You're going to be doing this for multiple data structures. The third part is implementing a multi-way try, and the fourth part is doing some problems regarding ternary search trees. It's also important that for all of the code you write, you should remember to check for memory leaks, as that will be tested via the autograder on Gradescope, and you will receive or lose points based on whether or not you have memory leaks. Okay, so recommendations: start early. Read over the PAs as soon as they're released. Obviously, this PA has already been released, but read over the README, and as soon as you download the code, please create all of the files you need to submit. So these are the .txt files. Obviously, it's not good to submit last minute, but if you end up needing to and you forget to add these files, then the autograder won't run, as it requires that all of the files are present. And then you should look at all of the .c and .h files before starting, because they have more information than the README. There's more of a description on what you need to accomplish for this PA. Now, part 1 is implementing the set ADT. For this, you need to do it for array list, linked list, red-black tree, and hash table. You need to, for all of these different files, implement size, insert, remove, and find. Now I'm just going to go through the underlying classes that are being used for each of these data structures. So the first one is vector. Then for linked list, it's list. For red-black tree, it's set. And for hash table, it's unordered map. If you look in the README, there are links to all of these classes and their documentation and the methods that exist. I'm not providing the methods that you should use here simply because it's good to get used to looking through documentation and searching for it on your own. But that's where you should be able to find the methods that you should be using for all of your implementations. So once again, these are linked in the README. Now, part 2 is implementing a multi-way try. So here's some resources that are available to you. I highly suggest using them. If you look at the STEPIC section, there's some pseudocode provided that's very useful as well. So please do look at these different resources. They're very beneficial. So now I'm going to go over some true or false problems and then some examples, and then we'll get into more of the code that you'll be writing. So true or false, in a multi-way trie, letters label nodes, and then true or false, an empty multi-way trie has no nodes. So if you want a second to think this over, please pause the video. I'm just going to move forward, and that's what I'll do for most of the questions, though I will remind you to pause where necessary. Also, all of these slides will be uploaded and linked in the description of this video, so you can go there if you want to see the links, because I know I just have them listed as here, and clearly you can't click on them in the video. So both of these are false. In a multi-way trie, letters are labeled by edges. Letters label edges, not nodes, and an empty multi-way trie is a single node tree with no edges. So next, in a multi-way trie, the node where isWord is true is the node with the final letter edge coming into it. And then when you remove a word from a multi-way trie, you should delete all of the edges representing letters in that word. So in the first one, in a multi-way trie, it is true that the isWord should be true for the node with the final letter edge coming into it for that word. And then when you remove a word from a multi-way trie, you should not delete all of the letters representing a word. You should just change the final node so isWord is false. The reason for this is if you think about it, if you have multiple shorter words that use the same letters, so card and car, and you decide to remove card, then you would actually remove letters that are required for another word in the multi-way trie. So now let's go through an example. And for this too, feel free to step through it slower at your own pace by looking through the slides. I'm going to go through it relatively quickly. So first you create the multi-way trie. This is an empty node that represents the root of the tree. Then inserting CSE. So first C, then S, and then E. And since there's nothing else being used, it's straightforward. All right. So now you are going to insert car. Okay. And then for the final one, all you end up needing to do is change this node to be isWord equals true. And the reason I'm using isWord is because it's relevant to your implementation. So I'll show you that in a second. So now here's an example where I would like you to list all of the words in the multi-way trie. I'm going to step forward pretty quickly, so please pause the video to go through this. Okay, so here are the words that are in it: ape, app, car, cart, do, and doggo. While you may think that dog is an option, and there's some other words in here such as art, those words, and apple, while those words technically the letters appear, they aren't actually words in the multi-way trie. So for your implementation, you are going to be creating a multi-way trie set using an unordered map. So for this, you need to implement size, insert, remove, find a constructor, and a destructor. Obviously, you should probably implement the constructor first. Also, it's important to remember that for this and for the other ones that you create, when you submit, everything needs to compile. Otherwise, you'll receive a 0 for all of your files. And these are essentially all or nothing. So if you get any of the methods wrong for the multi-way trie set, you won't receive credit for this section. So please do start early and make sure you understand how to implement these functions. So for the multi-way trie, you have the root node of the multi-way trie and then num elements. And num elements represents the total number of elements in the multi-way trie. So this is the number of words, not the number of nodes or edges, the number of words. And this is very important for your implementation. And then we have nodes, which are used in the multi-way trie. These nodes consist of two things, isWord and children. isWord is a Boolean to tell you whether this node is a word node or not. And then children is the children of that node. So now for part 3, ternary search trees. So here are some resources. Similarly, there's a David Gaia's visualization, there's practice in Stepic, and a video. So for the true or false, the questions are: in a TST, letters label nodes. In a TST, a node is marked as a word if it is the last node representing a letter in the word. And an empty TST has no nodes. all of these are true. So in a TST, letters label nodes, whereas in a multi-way trie, they label edges. In a TST, a node is marked as a word if it is the last node representing a letter in a word, and an empty TST has no nodes. This is different from a multi-way trie, where an empty multi-way trie has one node. Now, here I would like you to list all of the words. In this case, once again, I would say pause the video as I am just going to move forward. So I'll give you a few seconds to pause. Okay, so this contains ape, app, car, cart, do, dog, and doggo. It's similar to the words that were in the multi-way trie, although in this case, dog is also included. Now for some miscellaneous things I wanted to cover, still related to the PA. So the current FAQs, if you started the PA before Wednesday evening, I don't know the exact time, you should go into settest.cpp and delete line 84, which should just say break. If your line 84 doesn't say break, then just leave settest.cpp the way it is. Now, if you can't access the starter code, it's linked in the FAQs. Some people have been having issues due to GitHub having some problems. And then some people are also having issues inserting into an unordered map. That is answered in the FAQs as well. And finally, remember that num elements, which I covered earlier for multi-way tries, is the number of words in the multi-way trie, not nodes or edges, words. Okay, so what is a better option, a ternary search tree or a multi-way trie? It's almost always the multi-way trie, though it's important to remember it uses a large amount of space in some cases, so that's why. So here is a table that shows the worst case and average case time complexities for the multi-way trie and the ternary search tree. Now, this is a nice little table, right? And if you want to see more tables like this, slightly different format, but equally beneficial, the final chapter in STEPIC is summaries, and it consists of a summary of the time complexities and the space complexities for all of the data structures. So I highly recommend looking at that and making sure you understand all of the reasons behind everything. But that's a very good resource to study for the midterm and just gain a better understanding of what the differences between the different data structures are and when not you should use the different data structures. Okay, so now I'm going to go over some examples of those visualizations and show you how you can use them to practice for the PA and for the midterm. So actually first I'm just going to show you some of the STEPIC steps that I think could be helpful for you. So here is some pseudocode for multi-way tries and implementing find, remove, and insert. I highly suggest taking a look, and this is linked in the slides. There's also a nice section on ternary search trees that has 2 example problems that you should go through and also gives some examples in the text that you can use for practice. The majority of the STEPIC sections, I think all of them, have either multiple choice questions or some sort of coding question that's very beneficial, not just for practicing for the PA, but for the midterm. And a lot of the text includes examples as well that you can go through on your own. So I highly recommend doing these if you haven't already. And even if you have, if you've got some wrong or there's some concepts you're unsure of, you can always redo the problems. Okay, so here's one of those visualizations that I mentioned. It's really nice because it actually lets you insert and delete and find the different nodes in this multi-way trie. And that's really great because it allows you to come up with your own practice problems, try to complete them, and then you can test what's supposed to happen here, or you can do it as you go. You could insert something, write down what you think would be inserted, and then insert it, and then move on to trying to delete it or something like that. And it actually takes you through each of the steps, so you get to see what happens. All right, so I'm just going to go through a couple of examples here just so that we can see them. But it's really nice as it steps through everything for you. Okay, and you can notice here that they're putting each letter in the node. I think that's just for visualization purposes. But if you notice, those letters also correspond to edges. And for your assignment, you're going to be doing it on the edge, as that is what's actually representing those letters. And then say we want to delete something. So here it shows the process of deleting. Though in this case, they actually delete all of the nodes. But for your purposes, all you should do is once you get to the final node for that word, you should just switch is word to false rather than true. You don't need to worry about deleting the nodes themselves. Okay, so this is a good visualization tool. As I stated, I'm going to show you the other one for ternary search trees. But please use these. There's also ones provided for a large number of other data structures. Okay, so here is the visualization for ternary search trees, and it is essentially not the same data structure, but you'll be doing the same things to be able to implement and remove things, which is really nice. And you can kind of just walk through this, and once again, it'll give you ones. I'm just showing this to you so you can see how good of a resource this is to create your own practice problems. But yeah, this is available for a good number of the data structures that you need to do, including, I believe, red-black trees and a few others. So I highly recommend. Actually, I will show you the list of them just so that you have that too in mind. Okay, so here is a list of all of the visualizations that exist. There's a lot of really nice ones. I don't know, some of you may have already found this for previous classes, but it's great for creating your own examples. There's a large number of ones that we already have, and that would be great for practice for the midterm. And there's other ones that'll be beneficial for studying for the final, and also just getting more practice for the reading quizzes and for the PAs. So I highly suggest checking this out.